force, children. Now let us consider one more example. So what I consider here is, I will consider a big wooden box or a wooden block. Okay, this is the wooden block which is placed on the floor. A big wooden block is placed on the floor. Now, let us imagine, no, two persons are enough for now. So, let us imagine two persons are trying to push the block. Now, imagine to my height, I have one big wooden block. I am applying force to push it. So, imagine the block is quite heavy. It is heavier. So, if I apply the force from this side, so according to the law concept of force, what should the body should move in that direction? Will it come upon me? No, it will. If I am pushing this direction, the body also has to move in the same direction. But it is not happening. What does it mean? The force which I am applying is on this wooden block is not sufficient in order to move it. So, from the previous example concept, then if at all the wooden block is not moving even after I am pushing means, do you think the balanced force is present there? Why? Because we studied now balanced forces acting on the body means the body remains to be in the stationary position or to be in the state of rest. Now, I am pushing the block by applying the force, but the wooden block is it is not at all moving. Means, do you think the balanced force is present here? Here two persons applied same amount of force from either side, so the box remains stationary. But here only I am pushing from one side, nobody is pushing the box from that either side. From the other side, children. Only I am trying to push the wooden block, but it is not at all moving. Means, still I say the balanced force is acting upon the wooden block from only one person. Is it possible? Yes, is it possible? Yes, it is possible, children. How it is possible? Only one force. I am applying the force. These two persons. So, okay, next two persons will come. Here in this example, two persons are trying to apply the force on these wooden blocks and trying to push it. Still, the wooden block is not moving. What is the reason behind it means? Of course, we understand by this that the balanced force is present, hence the body as object, the wooden block is not moving. So, one force is the force which we are applying to push it, which is the one more force present here, that is balancing the force means. Of course, children, it is the, any idea you got in your minds? It is of course none other than the frictional force. It is none other than the frictional force, children. Yes, no, now I am standing on the floor. I am able to stand on the floor because the frictional force is present between the floor and my feet. As now, between my feet and the floor, there is frictional force present. Now, with the help of chalk, I am able to write on the board. Why? Because there is frictional force present between the chalk and the blackboard. Like this, children, any work you do, you are able to ride the bicycle. Why? Because there is frictional force present between the tire and the road. So, everywhere you see, the frictional force is present, children. Here also, even though I am trying to push the wooden block, heavier wooden block, it is not at all moving. Why? One force acting on the wooden block is the force which is applied by me or by this person, if you think. The other force which is avoiding it from moving forward is, that is the frictional force which is present between the wooden block and the surface of the wooden block and the floor, children. So, the frictional force which is applied by the floor, which is present between the floor and the wooden box, and the force which we are applying in order to move the wooden block, both are getting balanced. How? We studied now in this case 3 Newton cancelling 0, the body is stationary. That is what is happening here, children. Yes, no? The frictional force between the wooden block and the floor, as well as the force which we are applying in order to move the wooden blocks, both are getting balanced. Hence, the wooden block is not moving. It continues to be in the state of rest. Hence, balanced force is said to be present here. Now, here also, we considered that both the persons are applying a force of 3 Newton. Hence, the box did not move and it remained in the state of rest. In order to make the box, move the box, what should be done here? Either first person or second person has to apply more force compared to each other so that it can move. That is the case 2 and case 3 which we studied, children. Here we studied now, if at all the first person is applying force of 2 Newton, second person is applying the force of 3 Newton, obviously whichever person is applying more force towards him, the box will move. Here the second person is applying force of 3 Newton which is greater than the force applied by the first person, that is 2 Newton. Hence the block moved towards him. Similarly here, if at all you want to move the wooden block, yes, no, imagine this is the rough surface. If it is a mosaic means easily it will move. So to understand that question may rise in your, so I will keep on the wooden mosaic. So what, it will be smooth texture, no? So it will easily slide, no? So let us imagine it is a rough surface. You have placed it on the tar road, let us imagine. So like that, any rough surface we have placed this wooden block now. So the frictional force is acting between the floor and the wooden blocks, we said. Now here, since more force was applied by the second person, he was able to pull it towards. Now somehow or the other I want to move this or push this wooden block. So what should I do? I should apply force greater than this frictional force, isn't it, children? If I apply the force, or if these two persons apply the force in this direction in order to move the wooden block, then the force which they are applying should be more than the frictional force which is present between the floor and the wooden block. Then only they can move the wooden block easily. So, suppose you say, but we don't know how much is the frictional force. Can you sit down there and check what is the frictional force present between floor and the wooden block? No, you can't do that. Instead, what you can do? You can add as many persons you want. 3 persons, 4 persons, like this. So, force get on adding up. Yes, no, the force will get added up. That is important. One more point. See, to 1 person 2 Newton means second person may apply only force of 1 Newton. He may be very weak person. Third person may be very strong. He may apply force of 5 Newton. So these 3 persons together they are pushing the wooden block. Means the forces will get added up like 5 Newton, 2 Newton, 3 Newton. 8 Newton of force is acting. Means 3 or 4 persons when they are pushing the block together, yes, it will overcome the frictional force which is present between the floor and the wooden blocks and it will move forward, children. So, we are unbalancing the force. Which force? Force which we are applying and the frictional force in order to make the wooden block to move. So, in this example also, we understood both the concept of balanced and unbalanced force, children. Hence, the statement once more we can apply here, which is that if at all the force is balanced, the body or the object continues to be in the state of rest. If at all the unbalanced force is present, then only the object or body starts to move. This is very, very important concept, children. So this is about the concept of balanced and the unbalanced force. So let us soon glance with your textbook once. As I said you children, as soon as you watch video, please go through the textbook, read the lesson once without leaving any one line or any one concept also. You will understand it better. That is what I mean. Now, in the last class, we studied all these examples, children, pulling, trolley, draw, on that we studied. So, balanced and unbalanced force in page 115 of your textbook. Here, the figure 9.3 shows two forces acting on a wooden block. So, the same experiment they are explaining here. Two persons are pulling in which direction? That they have. Next, one more example of the same thing, that is the wooden box is applied. And one more thing I forgot to tell you children. The force here we wrote +3 -3 and cancelled it off. What reason I gave you? It is because the force applied by both the person are acting in opposite direction. Here also children, in this case also, if at all you are applying the force from towards this side in order to move the wooden blocks towards the right, then the frictional force it is opposing means it will be acting in the opposite direction to the force which you are applying. So only you are not able to move the wooden blocks. This is very important. Here also the force acting are in opposite direction. This can be experienced when you are riding the bicycle, children. Yes, no, if at all the upward road you have to apply more force in order to pedal the bicycle. But if you are going in the, don't want up, down and all. Slant road only. So see the road, what you say, the straight road. So you are riding the bicycle now. You will ride the bicycle for some distance and for a moment you stop pedaling. As soon as you stop pedaling, will the bicycle come to rest immediately? No. But what will happen? It will move for some distance. Again, in order to increase the speed, you need to pedal them. This you might have experienced. Yes, no, while riding the bicycle. So, the moment you stopped pedaling, still the bicycle moved to some distance and then came to end or rest. So, that distance is there, no? What is it making the bicycle to move even after you stopped pedaling means, children? Again, this concept of friction force come into play there. Again, this concept of frictional force come into play. What is happening means, as I said you, there is frictional force present between the tire of your bicycle as well as the road. So that frictional force is acting in opposite direction in whichever direction you are riding the bicycle. If you are riding the bicycle in the forward direction, the frictional force is acting in the opposite direction. So there also you are able to move the bicycle for some distance even after you stop pedaling due to the same concept that we shall understand. So here two forces are acting in opposite direction. That point to keep in mind, I forgot to tell you while explaining. Now, let us consider the second example explanation in your textbook. What happens when some children try to push a box on a rough floor? If they push the box with a small force, the box does not move. Why? Because of friction acting in a direction opposite to the push. See, please underline that in your textbook. This frictional force arises between two surfaces in contact. In this case, between the bottom of the box and the floor's rough surface. It balances the pushing force and therefore the box does not move. The force is getting balanced. The children push the box harder, but the box still does not move. This is because the friction force still balances the pushing force. Yes, no, the force is getting balanced. Pushing force means the force which you are applying is the pushing force here. Frictional force, they both are acting in opposite direction. If they are equal, then the body will not move and it remains to be in the state of rest. That is what they are about to tell. So this is because the friction force still balances the pushing force. If the children push the box harder still, the pushing force becomes bigger than the frictional force. There is an unbalanced force and hence this object starts moving. That is what we learned. Yes, no, children? If at all you overcome the frictional force, means you should apply force which is greater than the frictional force. Then only the force will get unbalanced and the wooden block will move. What happens when we ride a bicycle? When we stop pedaling, the bicycle begins to slow down. This is again because of the frictional force acting opposite to the direction of motion. In order to keep the bicycle moving, we have to start pedaling again. It thus appears that an object maintains its motion under the continuous application of an unbalanced force. Very important, children. Please underline this sentence. So, here, what we did is the pushing force, that is the force which we are applying is more than the frictional force present here, means the wooden block will start to move. Yes, we are happy. But if you apply force and leave it and joining your hands, will it move, continue to move? No, again it will come to rest. Again the force will get balanced. So again if you have to apply more force compared to the frictional force, and hence again it will move. So unless and until the forces are unbalanced, only the object will continue to move. If you stop applying the force, again if at all the force become unbalanced, again it will come back to rest. So unless and until the unbalanced forces are acting on the body continues to be in the state of motion. Once the force becomes the balanced force, then the object or the body comes to rest. This is very, very important concept, children. This you can understand it better with the help of you riding the bicycle. When you stop pedaling, the bicycle will slow down, the speed of the bicycle comes down, and only after it can move only up to certain distance. After that, again you need to pedal in order to move further. The frictional force between the tire and the road will become balanced, means the bicycle will come to rest, it will stop. In order to overcome that force, again you need to pedal, means you are applying the force which is greater than the frictional force present between the tire and the road, children. So, in order to keep the bicycle moving, we have to start pedaling. It is thus appears that an object maintains motion under the continuous application of unbalanced force. However, it is quite incorrect. There may be few examples or situations where it may vary, children. So they are telling this statement, however, it may be incorrect. An object moves with a uniform velocity when the force, that is pushing force or frictional force, acting on the object are balanced and there is no net external force on it. If an unbalanced force is applied on the object, there will be change either in its speed or in the direction of its motion. Thus, so here, when unbalanced forces are acting on the body, the body will be in the state of rest, means of course its speed or this position is not changing because it is at rest. But in case of unbalanced forces acting on the body, children, both the speed and direction will change. Yes, no, speed will change. If you are applying more force, it will move fast. If you are applying less force, but which is more than frictional force, then it will move slowly. So, there is change in the speed, and in whichever direction you are applying the force, in the same direction the object is moving, but the frictional force is acting in the opposite direction, means the speed and the direction, both the quantities are changing for that object. Hence, when the balanced force are said to be acting on the body, there will be no change in the speed or change in the direction of the body, whereas when unbalanced forces are acting on the body, there will be change in the speed as well as its direction. This you need to understand. Thus, to accelerate the motion of an object, an unbalanced force is required. In order to move the object, unbalanced force is required. If the balanced forces are acting, then it remains to be in the state of rest. Maybe a table, if you consider, children, it will be in the state of rest. Do you think no force is acting now? No. The force is acting, means the frictional force is present. No other force is acted on the table now. Hence the force is balanced and it remains to be in the state of rest. Now if you go push against the frictional force, the force become unbalanced now and hence it will move. So in order to move any object or in order to make any object to accelerate, what is required? The unbalanced force is required. And the change in its speed or thus, to accelerate the motion of an object, an unbalanced force is required, and change in its speed or in direction would continue as long as this unbalanced force is applied. However, if the applied force is removed completely, the object would continue to move with the velocity it has acquired till then. Again, what it means is, see, as long as you are applying the force, these three persons are applying force on the wooden block against this frictional force, the unbalanced force will be present and the wooden block continues to move. But as soon as these three persons stop applying force, again the wooden block will remain stationary. The force become balanced. Similarly, in case of riding the bicycle, which we consider, children, unless and until you are pedaling, it will move. If you stop pedaling, it will slow down, but it will suddenly not stop, as I said. It will move to certain distance and then only the bicycle will come to rest. So, why it is moving that direction even though the force became balanced, means the first only it gained some velocity when you are riding it very fast, no? So, it is spending that velocity, there. The stored velocity has been spent there in order to move that distance before coming to rest. So unless and until the unbalanced forces acting on the body continues to be in acceleration or in motion. If the unbalanced force is removed from the body, then the body will come to rest. The body will come to rest. Hence, the unbalanced force is always required to be acted on a body in order to keep it in the state of motion. So, this is about the concept of balanced and unbalanced force, children. So, please read the textbook and you can write any two examples of your own in case of this balanced and unbalanced force. Next, you have, children, first law of Newton's first law of motion, second law of motion, concept of inertia and mass, and the mathematical form of that. As I said you, as far as your new syllabus is concerned, the number of periods for this lesson is reduced as you have studied this Newton's first law, second law and its mathematical form already in class 8. So what I will do is by this time I send you the video, last session also I said you, please read 8th standard textbook with respect to this Newton's laws of motion. Study all the 3 motions and keep yourself ready so that I can explain only in brief with these concepts of first, second and third law of motion. Thank you.